Hello everyone and welcome again to Human-Computer Interaction, and we are now in our chapter 3, and for this chapter we will be learning the human factors as HCI theories. Okay, so our learning objectives are the following: human information processing, we're going to discuss that one, task modeling and human problem solving model, human reaction and prediction of cognitive performance, and also sensation and perception of information. That includes the visual, aural, tactile and haptic, multimodal interaction, and also we're going to discuss the human body ergonomics or the motor capabilities, what is the fitz law is all about, and then the motor control. Okay, so I hope you're going to learn something from this video. Oh wait. Okay, so the human information processing. So I believe that you are familiar with this, with how the information is being processed by a human being. Okay, so any effort to design an effective interface for human-computer interaction, or HCI, requires two basic elements. Okay, you need to understand the computer factors, the software and the hardware. Okay, so you should have a little bit idea on how computer works. Okay, what is a software? What is a hardware? No? What are the different parts of the computer? Okay, and then of course, next is the human behavior, your behavior, the user's behavior. Okay, so in this chapter, we will gonna take a look at some basic human factors that constrict the extent of this interaction. Okay, so as the main underlying theory of HCI, human factors can largely be divided into. So these are the human factors. First is the cognitive science. Okay, so the cognitive science, it's which explains the human's capability and model of conscious processing of high-level information. Okay, when there is a processing of a high-level information, that is called the cognitive science. Okay, and when we say ergonomics, which elucidates how raw external stimulation signals are accepted by our five senses. Okay, are processed at the pre-attentive level and are later acted upon in the outer world through the motor organs. So we're going to be discuss the different senses, okay, on how humans interacts with the computers or any devices. Okay, and that is what we called the ergonomics. Next. Okay, so we're going to take a look now the different human factors knowledge. Okay, so first is the task or interaction modeling. So when you actually decide to design system, you need to of course evaluate, what would be how the user is going to interact. So you need to create some models. Okay, so formulate the steps of how human might interact to solve and carry out a given task or problem, and derive the interaction model. Okay, so a careful HCI designer would not neglect to obtain this model by direct observation of the users themselves, but the designer's knowledge in cognitive science will help greatly in developing the model. Okay, so you need to of course again identify what would be the different tasks or what would be the expected output of the created system. Okay, next is the prediction, assessment and evaluation of interactive behavior. Okay, so you need to understand and predict how human might react mentally to various information presentation and input solicitation methods as a basis for interface selection. Okay, and also evaluate interaction models and interface implementations and explain or predict their performance and usability. So you need to know how to predict. You need to know how to assess and evaluate. Okay, so that's I believe it's understandable that when you create a system, you should be thinking about oh, what if the user were going to do this, we're going to do that, no? What would be the positive and negative scenarios? Okay, so let us say there's a login button, no? The login button will of course allow the users to log in, okay, when he click that. And once after the click ni user tong login button, wala they say function. So you need to know, okay, what would be the interactive behavior between the human, the user, and your software or your system kay mo ang gi-design. Okay, next is the task modeling and human problem solving model. Okay, how to model task and what are different from human problem solving model. Okay, so human problem solving or information processing, wait guys, effort consists of the following important parts. Okay, take note. Sensation, which senses external information. Okay, example, visual, aural, and haptic for the sense of visual, hearing, sound, touch, something like that. And perception. Okay, the perception, which mali siya, nadiri dapat na. Okay, so which interprets and extracts basic meaning of the external information. Okay, so that is the difference between the sensation, again, which senses external information, and then the perception is which interprets and extracts the basic meanings. Okay, so perception, guess is that. And next, memory. Okay, so of course all of us humans has memories, no? Even computers has memories, which stores momentary and short-term information or long-term knowledge. Okay, so this knowledge includes information about the external world, procedures, rules, relations, schemas, candidates of actions to apply, and current objective. Okay, example, accomplishing the interactive task successfully. Okay, or the plan or action or etc. So that's pretty basic. Okay, next, decision maker or executor. Okay, the decision maker, this will formulate and revise a plan, then decides what to do based on, wait lang, alright, based on the various knowledge and the memory, and finally acted out by commanding the motor system. Okay, so for example, when to click the mouse left button, no, or right click, left click, something like those things. Okay, so those were how are you going to task modeling, that is the task modeling and human problem solving model. Okay, so here it is. This is the representation. Okay, let us say there is an information. Okay, an information, it will run through the sensation, and after with the sensation, your perception. Okay, it goes to the memory, right? It goes to the short-term memory, and then it goes back and forth to the long-term. Okay, then mobalik din sa perception nimo, and then we're gonna, because of that perception and then short-term, long-term memory, then we're gonna make a decision, and after making a decision, of course, we take an action. Okay, so this is the overall human problem-solving model and process. This is what can happen. Okay, so for example, when I click an icon in a computer, I know in my Android phone, okay, so there is a sensation, huh? And then what is my perception then? The next thing that can happen, so it will gonna store into my memory short term, and then I'm gonna remember that one, and then of course I decide, no, the user, after clicking this button, the user will be navigated to this page or etc. And then what will be the action? Okay, so that is again the overall problem solving model and process. For the more detailed view of the decision maker or executor, of course, what you're going to do in order for you to model a task or you need to define the problem. Okay, so after defining the problem, you gather knowledge. The basic one. Okay, consider possible actions. What will be the possible actions? Okay, you create a plan, and then after creating a plan, you execute, and then you observe the results. Okay, so if the problem is not solved, you go back to gathering the knowledge, and then if after observing the result, then the problem is solved, the process will be terminated. Okay, so as easy as that. So a simple illustration would be insecurity. You know, the user will not be able to access dashboard of your system without, you know, registering or log into the application. Okay, so what is the problem in there? Problem would be kung wala si login page, then automatic siya maka-access. So what are you gonna do? You need to create an interface to this, to that. Okay, is the user will be able to log in if invalid ang username and password niya yung input. So kung dili, unsa man nimo kailangan para would you be para di siya makalagin. Okay, so those are some very pretty basic illustrations for that, guys. Next, let's move on to human reaction and prediction of cognitive performance. Okay, so we can also to some degree predict how humans will react and perform in response to a particular human interface design. This is really true, and I absolutely agree with this one. So we can consider two aspects of human performance. One that is cognitive and other is ergonomic. Okay, so okay, so the human reaction and prediction of cognitive science, or what is this cognitive now? Okay, so Norman and Draper spoke of the goal of execution or evaluation, which explains how users can be left bewildered and not perform very well when an interactive system doesn't offer certain actions or does not result in a state as expected by the user. Of course, imagine, okay, there's a button, register button. So it is expected na kung imo nang i-click ng register button, you will be registered to the user, no, providing your name, your email, your phone number, and etc. And then wala nahitabo pag click mo sa register button. Okay, so that is how you actually react, you know, how you interact with the system. So such a phenomenon would be a result of an interface based on an L-modeled interaction. Okay, so if the user, you know, was not able to, wala yung nakuha without yung expected result, it will be again based on an L-modeled interaction. So it's very necessary, guys, that when you create a system, it should be modeled properly. Okay, the task must be defined properly, and yeah, should be planned out very well. Okay, so the mismatch between the user's mental model and the task model employed by the interactive system creates the goal. Okay, on the other hand, when the task model and interface structure of the interactive system maps well to the expected mental model of the user, so the task performance will be very fluid. It's very necessary that when you create a system, you must predict, what would be the expected output when the user use this kind of feature, something like that. So it's all up to you, it's all your choice. So you need to plan it out. Okay, just take a look at this one. This is the predictive performance assessment with the GOMS. GOMS meaning goals, operators, methods, and selection. Okay, so many important cognitive activities have been analyzed in terms of their typical approximate process time. So in terms of typical approximate process time. Okay, so for example, for single chunk retrieval from the short-term memory, encoding or memorizing of information into the long-term memory, responding to visual stimulus and interpreting its content, and estimates of time for typical desktop computer operations from GOM. Okay, so for example, keyboard input. Okay, the time estimate would be something like this, 0.2 seconds, or when a user point with mouse to something in the display, you press or release mouse button, how many seconds will it takes, you click a mouse, home hands either the keyboard or mouse. Okay, so this where this is the predictive performance assessment, but with Go. So this is actually a sample. Okay, when you type in something in the computer. Okay. Next. Wait. Okay. Next that we're going to discuss would be the sensation and perception of information. Okay, so this is very important when you actually create a really good HCI design. So you must know the basic concept of sensation and perception of information. So humans are known to have at least 5 senses. Okay, so grade 1 parang gituduan na ta. Okay, so among them, those that would be relevant to HCI are the modalities of visual. Of course, we're using our eyes. No? The aural, no, the hearing, the haptic or the touch, force feedback, and tactile sensation. Okay, so don't worry because we're going to discuss each senses, no, on the next slides. So taking external stimulation or raw sensory information, sometimes computer generated, and then processing it for perception is the first part in any human-computer interaction. Okay, so naturally, the information must be supplied in a fashion that is amenable to human consumption, that is within the bounds of a human's perceptual capabilities. So let's start. We're gonna go with the visual. Okay, so visual modality is by far the most important information medium. Of course, how can you get the information, diba? Kung close in eyes. Okay, so we're gonna discuss next would be with the sound na makakuha ng information. But as of for this slide, it's very important, no? The visual modality is by far the most important information medium. So over 40% of the human brain is said to be involved with the processing of visual information, okay, through our eyes. So again, it's over 40% of human brain, no? Muna nang gigamit. At least mas dali maka course create, no, of information through our eyes. Okay, so in visual, we have this visual and display parameters. Okay, so first is the field of view. So the field of view, or FOV, this is the angle subtended by the visible area by the human user in the horizontal and vertical direction. Okay, so as you can see in the image, the shaded area illustrates the horizontal view. Okay, so the human field of view is nearly 180 degrees in both the horizontal and vertical direction. Okay, so as you can see in the figure, a user viewing a display system. So this is sample ng display system. The shaded area illustrates the horizontal field. Yan, yan sila of the view. Okay, shown to be much less than the actual for illustration purpose. This is just an illustration purpose. So while the dashed line is the same as offered by the display. Okay, so the display offers different fields of view depending on the viewing distance. Dotted line in the middle, as you can see here, this is the dotted lines. So the oval shape, okay, the oval shape in the display represents the approximate area for which high details are perceived through the corresponding focal area in the user eyes. Okay, so this is the sample. Yan. So again, there is a field of view when it comes to the visual and display parameters. Okay, next is the viewing distance. So how the users view, no? Yung distance gikan sa imong device kay imong eye. Okay, so the viewing distance. So this is perpendicular distance to the surface of the display. Okay, again, a perpendicular distance to the surface of the display. Viewing distance, as you can see here, the dotted lines, this is the viewing distance, may change with user movements. So you may have observed, may time na binaduol kini mo, diba? May time nga gapalayo pud ka. Okay? So, however, one might be able to define a nominal and typical viewing distance for a given task or operating environment. Okay? So there's a viewing distance. And next, also in a visual display parameters, there is a display field of view. So again, guys, do not be don't ask yourself ato na siyang ipang discuss. We need to know this. We need to know the basic concepts, okay, in order for you to develop a really good design. Okay, and then display field of view. In the display field of view, when it comes to the visual and display parameters, this is the angle subtended with the display area from a particular viewing distance. Okay, so note that for the same fixed field display area, the display FOV will be different at a different viewing distance. So again, in the figure 3.6, the display FOV is denoted with the dashed line. Okay, dashed line. So the display offers different fields of view depending on the viewing distance or dotted line in the middle. Okay, so that is the display field of view. Next is the pixel. The pixel is a display system. A display system is typically composed of an array of small rectangular areas called pixels. So familiar sa mga mana, no? So kanino kakita sa screen karon, it is of course composed with different pixels. Gagmay kina siyang mga square. So I believe you are familiar with this, no? Kabalo naman ng pixels. Okay, the display resolution. Okay, so when you design, you need to know para asa na siya, no? Okay, you need to know the different display resolutions. So as we have observed, natin mga laptops, natin mga smartphones, so may mga different resolutions, tablets. Okay, so this is the number of pixels in the horizontal and vertical directions of a fixed area. Okay, so that is just the basic one. The visual acuity. Okay, the visual acuity, in effect, this is the resolution perceivable by the human eye from a fixed distance. Okay, this is also synonymous with the power of the sight, which is different for different people in age group. Okay, so again, this is just the resolution perceivable by the human eye from a fixed distance. So that is the visual acuity. Okay, next, when it comes to the visual, it's the detail and peripheral vision. Okay, so the human eye contains two types of cells that react to the light intensities in different ways. The cones, which are responsible for color and detail recognition, are distributed heavily in the center of the retina, back of the eyeball, which subtends about 5 degrees in the human FOV or field of view, and roughly establishes the area of focus. Okay, so the oval region in 3.6, as you can see in here, shows the corresponding region in the display for which details can be perceived through these cells. So on the other hand, the rods are distributed mainly in the periphery of the retina and are responsible for motion detection and less detailed peripheral vision. So which details may not be sensed, the rods contribute to our awareness of the surrounding environment. So this is just the concept. I-imagine lang ninyo, no? Inanang-relatable, but we'll not gonna explain further kung unsa na siya. Basta all you have just to do is there is two types of cells that react to the light intensity, the cones and then the rods. Okay, so if you wanted to learn more about how our eyes work, then study the other field, of studying the human eye. Next, the color, brightness, and contrast. I believe kabalo na kayo mo ani because you always ga-edit with mga photos ninyo, there is a really good na mga brightness, no, mga contrast, adjust mo dara, okay? So when we say brightness, again, the amount of light energy emitted by the object. The brightness. The color, human responds to different wavelengths of light, namely for those corresponding to red, green, blue, and parameters. That is color. Okay, so a color can be specified by the composer of the amounts contributed by the three fundamental colors, and also by hue or the particular wavelength. The saturation, okay, the saturation meaning the relative difference in the major wavelength and the rest of in the light, and brightness value or total of the light energy. Okay, so this is a sample. This is the figure in figure 3.10. The color specification by hue for particular predominant wavelength. The saturation, again, is the relative difference in the major wavelength and the rest. And the value or brightness, this is the total amount of light energy. Okay? So, kabalo ko gagamit ang Lightroom, no? When you edit a photo, mas mailhan ninyo dito kung i-adjust ninyo ang brightness, mag-add mo sa yung colors, no? Sa yung contrast, something like that. Okay? So again, when you develop a system, you need to consider the color, the brightness, and then its contrast. Next, the contrast. Okay, the contrast, by the way, is this is the relative difference in brightness or color between two visual objects. So contrast in brightness is measured in terms of the difference or ratio of the amount of light energies between two or more objects. Okay, so the recommended ratio of the foreground to background brightness contrast is at least 3:1. Okay, then the color contrast is defined in terms of differences or ratios in the dimensions of hue and saturation. So it is said that the brightness contrast is more effective for detailed perception than the color contrast. Okay, so as you may observe, coding of information in the map, okay, using contrast and brightness left, and then using the color in the right. Okay, so I believe and I hope you guys have already an idea, you know, how contrast works. Next, the pre-attended features and high-level diagrammatic semantics. Okay, so detail, color, brightness, and contrast are all very low-level raw visual properties. So before all these low-level part features are finally consolidated for conscious recognition of a larger object through the visual information processing pipeline, pre-attended features might be used to attract our attention. Okay? Wait. So, what are these pre-attended features? Pre-attended features are composite, okay, primitive, and intermediate visual elements that are automatically recognized before entering our consciousness. So, typically within 10 milliseconds after entering the sensory system, these features may rely on relative difference in color, size, shape, orientation, depth, texture, motion, etc. Okay, so as you can see here in the chapter 12, this is just an example. This is examples of pre-attended features for attention focus based on differences in size, shape, and orientation, and application to icon design in the right. So again, you're familiar with the different icons, no? Or yeah, na pwede mo siya gamitan, no, when you actually create your own system. Okay. Next is the aural. Okay. So next to the visual, the aural modality or the sound is perhaps the most prevalent mode for information feedback. So again, naiuban sa tuan ng mga users na possible dili sila kakita, diba, they're blind. So how they actually get the information? It's through their ear, no? Through sound. So the actual form of sound feedback can be roughly divided into 3 types. Simple beep-like sound, short symbolic sound bites known as the icons, The paper example for that would be the paper crunching sound when a file is entered into the trash can for deletion. Kabalo ko nakadome naman when you drag something to the recycle bin, din mag-pop up din siya, di ba? Kung di mo bagay siyang i-delete, something like that. And then the relatively longer as is sound feedback that is replayed from recording or synthesis. Okay, again, the actual form sound feedback can be divided into three types. We have simple beep, short symbolic, and relatively longer as is sound feedback that is replayed from recording or synthesis. Okay, so let's discuss the different aural display parameters. First is the intensity or amplitude. Okay, it refers to the amount of sound energy and is synonymous with the more familiar term volume. Okay, kabalo man tag may mga volume, di ba? Pero may magita magpa-music, no? There's a volume, okay? Intensity is often measured in the units of decibels or dB. So a logarithmic scale of sound energy where 0 dB corresponds to the lowest level of audible sound and about 130 decibels is the highest. Okay, so it is constructed to know that the decibels of different sounds as a guideline in setting the nominal volume for the sound feedback. Okay, so the 0 is the weakest. Wala na, no? 30, the whisper. 50 is the office environment. The normal conversation, 60, that is intensity. The rock band, just 110, and then again, the highest is 130. This is the pain threshold. Kung 100% na nila, no? Okay? So again, that is when we are talking about the aural display parameters or the sound. Next is, okay, sound can be viewed as containing or being composed of a number of sinusoidal waves with different frequencies and corresponding amplitude. The dominant frequency component determines various characteristics of sound, such as pitch, low or high, timbre, no, which is the instrument, and even directionality. No, where is the sound coming from? Okay, so humans can hear sound waves with frequency values between about 20 and 20,000 hertz. Just get a simple concept, okay, on how we actually hear. Oh, I think, okay, it's the same slides. So let's move on to the next. The phase, okay? Phase, it refers to the time differences among sound waves that emanate from the same source. So phase differences occur, for example, because our left and right ears may have slightly different distances to the sound source, and as such, phase differences are also known to contribute the perception of specialized sound such as stereo. Okay. Next is other characteristics. We further point out a few different aural feedback from the visual. So first, sound is effectively omnidirectional. Okay, so for this reason, sound is most often used to attract and direct a user's attention. Okay, however, as already mentioned, it can also be a nuisance as a task interrupter. Okay, for example, a momentary loss of context by the startle effect. Making use of contrast is possible with sound as well. For instance, auditory feedback would require a 50 to 30 decibels difference from the ambient noise to be heard effectively. Okay, so differentiated frequency components can be used to convey certain information. Next, when it comes to aural modality as input method. So far, the aural modality has been explained only in the context of passive feedback. So as for using it actively as a means to input to interactive system, two major methods are the keyword recognition and natural language understanding. So I believe you are familiar with the mga voice commands, mga software applications, no? Para kay okay Google, okay? So it uses our sound, okay? Sinadunggan si din niya. And then, yeah, keyword recognition. What would be different keywords and unsa din yung action, no? Kung iya tong ma-hear. Then, the natural language understanding, okay? You need to, of course, understand. Okay, so let's move on with the tactile and haptic. So when we say tactile and haptic, it's all about, you know, the sense of touch. So haptic is defined to be the modality that takes advantage of touch by applying forces, vibrations, or motions to the user. Thus, haptic refers to both the sensation of force feedback as well as touch or tactile. So when we say tactile, it is when you are applying, no, a touch, no? When you are touching your smartphone, okay. So when haptic, when there's a sensation of force feedback with touch, okay. So for convenience, we will use the term haptic to refer to the modality of sensing force and kinesthetic feedback through our joints and muscles. So even though any force feedback practically requires contact through the skin, and the term tactile for sensing different types of touch, example, texture, light, pressure, contact, pain, vibration, and even temperature or through our skin. Now, touch that sa imong smartphone. So that involves tactile and haptic or haptic. Okay, so in a tactile, there is the tactile display parameters. So the skin sensitivity to physical object is different from the human body. The fingertip is one of the most sensitive areas and is frequently used for HCI properties. So you may have observed na natin mga touch screens, di ba? So the fingertip can sense object. Okay? Ang imong fingertip daw, anong ka na ang gamit? Can sense object as small as 40 micrometer in size. Kasi pag gamay kay siya, once ka matouch na sa imong skin, sa imong fingertip, would be na interaction gakahitabo. Okay? So the vibration frequency. In a vibration frequency, rapid movements such as vibration is mostly sensed by the Pacinian corpuscle, which is known to have a signal response range of 100 to 300 Hz. So vibration frequency is about 250 Hz is said to be optimal for comfortable perception. Okay, so there is a vibration frequency. Next is the pressure threshold. The pressure, the lightest amount of pressure humans can sense is said to be about 100 Nm2 squared. Okay, so for a fingertip, this amount is about 0.02, and for the fingertip area. Okay, wait. By the way, when we say n/m squared, this is the Newton or Newton per meter squared. That is the unit used in touch. So the maximum threshold is difficult to measure because when the force or torque gets larger enough, the kinesthetic sense are to start to operate. So on this threshold will greatly depend on the physical condition of the user, either strong versus a weak user. Okay, so again, just learn the basic concept when it comes to the pressure threshold. So as mentioned, there are many types of a tactile stimulation, such as the texture, pressure, vibration, and even temperature. Okay. So for the purposes of HCI, the following parameters are deemed important in the same goals for the display system, providing the tactile-based feedback. Okay, so physical tactile sensation is felt by a combination of skin cells and nerves tuned for a particular types of stimulation. Example, the masonry corpuscle for slight pressure or slow pushing, or the stimulation signal frequency of 3 to 4 Hz, Merkel cells to flutter and textured protrusion surfaces or 0.3 to 3 Hz, the Pacinian corpuscle for more rapid vibratory stimulation from 10 to 500 Hz, and Ruffini endings for skin stretch. So medyo maduguan kayo guys, no? But just got to know the basic, no? More na siya ang kasabot niya. So cells and nerves in the skin, no? Tanan mo ni siya. Okay? So again, we will not really, di na kaya natin na siya deeply discuss, no? Kung gusto mo makatuon pagidana about our skin, then search it in Google and study, no, ng mga different parts of skin na to. Okay, so let's move on with the next slide. Okay, so along with the tactile feedback, haptic feedback adds a more apparent physical dimension to interaction. So force feedback and movement is felt by the cells and nerves in our muscles and joints. For instance, the muscle, spindle, or tendon takes the inertial load, and the Pacinian or Ruffini or Golgi receptors sense the joint movements, pressure, and torque. So here it is. Okay. Next. The simplest form of haptic device is as simple as electromagnetic latch that is often used in game controllers. So it generates a sudden inertial movement and slow reposition itself for repeated usage. Normally, the user holds onto the device, and inertial forces are delivered into direction relative to the game controller. Such a device is not appropriate for fast-acquiring interaction, or example, successive gunshots, or for displaying a continuously sustained force. For example, just leaning against a wall. Next, more complicated haptic devices are in the form of robotic kinematic chain, either fixed on the ground or worn on the body. So, as kinematic chain, such devices offer higher degrees of freedom and finer force control. So as you can see, this is our example. Okay, in figure 3.17. So for the grounded device, the user interacts with the tip of the robotic chain through which a force feedback is delivered. So the sensors and the joints of the device make it possible to track the tip, or the interaction point within the three-dimensional operating space, or 3D. So the important haptic display parameters are the following: the degrees of freedom, meaning this is the number of direction in which force or torque can be displayed; the force range, that is, should at least greater than 0.mn; the operating or interaction range, or how much movement is allowed through the device; and the stability. Stability, or how stable the supplied force is felt to be. Okay. So stability is in fact a byproduct of the proper sampling period, which refers to the time taken to sense the current amount of force at the interaction point and then determine whether the target value has been reached and reinforce it. So it is a process that repeats until a target equilibrium force is reached at the interaction point. Okay, So the ideal sampling period is about 1000 hertz. And when the sampling period falls under a certain value, the robotic mechanism exhibits instability. Okay, so example, exhibited in the form of vibration, and thus lower usability. So the dilemma is that providing a high sampling rate requires a heavy computation load, not only in updating the output force, but also physical stimulation. Okay, so example, that be to check if the 3D cursor has hit any vertical object. So therefore, a careful, satisfying solution is needed to be balanced the level of the haptic device performance and the user experience. So this is the sample illustration for that one. Okay, next, the multimodal interaction. So conventional interfaces have been mostly visually oriented. However, for various reasons, multimodal interfaces are gaining popularity with the ubiquity of multimedia devices. So by employing more than one modality, interfaces can be more effective in a number of ways, depending on how they are configured. Okay? So in a multimodal interaction, there is its properties. First is the complementary. In the complementary, different modalities can assume different rules and act in a complementary fashion to achieve specific interaction objectives. Okay, so for example, an oral feedback can signify the arrival of a phone call, while the visual displays the caller's name. Okay, that is complementary. And then the redundant meaning different modality input methods or feedback can be used to ensure a reliable achievement of the interaction object. So for example, the ring of a phone call that can be simultaneously oral and tactile to strengthen the pickup probability. Okay, and the other one is the alternative. So providing users with alternative ways to interact gives people more choices. So for instance, example again, a phone call can be made either by touching a button or by speaking the caller's name. So thereby promoting convenience and usability. So a multimodal interaction. Okay. So for multimodal interfaces to be effective, each feedback must be properly synchronized and consistent in its representation. So for instance, to signify a button touch, the visual highlighting and beep sound must occur within a short period of time, so around less than 200 milliseconds, be recognized as one consistent event. Okay, so the representation must be coordinated between the two. In the previous example, if there is one highlighting, then there should also be a corresponding beep. Okay, when inconsistent, the interpretation of the feedback can be confusing, or only the dominant modality would be recognized. Kailain po kayo guys if ang delete nimo na ay beep, tapos pag click nimo sa icon, ni-display ang modal, and then ang confirmation, and then ang beep niya is after pa ng na-delete na ang file. Sumurog ina na ba? So there should be consistency between the interface and then the oral na magagamit. Okay, the human body ergonomics or the motor capabilities. So we're gonna learn the basic principles. Okay, so far we have mostly talked about the human cognitive and perceptual capabilities and how display or input systems must be configured to match them. So to be precise, ergonomics is a discipline focused on making products and interfaces comfortable and efficient. Thus, broadly speaking, it encompasses mental and perceptual issues. Although in this book, we restrict the term to mean ways to design interfaces or interaction devices for comfort and high performance according to physical mechanics of the human body. For HCI, we focus on the human motor capabilities that are used to make input interaction. So we start with the fitz law and human motor control. Okay, kinsa man ni? What is the Fitz law? The Fitz law is a model of human movement that predicts the time required to rapidly move to a target area as a function of the distance to and the size of the target. Okay, so the movement task index of difficulty or ID can be quantified in terms of required information amount in the number of bits. So from the main equation in 3.19, just look at that equation. The actual time to complete the movement task is predicted using a simple linear equation, where movement time mt is a linear function of ID. Okay, so again, the movement task is predicted using a simple linear equation where movement time mt is a linear function of ID, or index of difficulty. Okay, so here's the formula. Okay, mt is equal to a plus b multiplied by id, and id equals to the log. So don't worry guys, there will be no calculation. We're just gonna get the basic principle of the Fitz law. Okay, so this is a formula where a and b are coefficients specific to given task. Thus, to reiterate, ID, index of difficulty, represents an abstract notion of difficulty of the task, while MT is an actual prediction value of a particular task. Okay? So the values for coefficients A and B are obtained by taking samples of the performance and mathematically deriving them by regression. Okay, this is the sample illustration. This is the illustration, guys. Deriving the actual movement time by fitting based on samples performance data. Okay, so again, no, in HCI na dito mga principles na gipanggamit pod in order for us kung giunsa no nabuhat man nila. Okay, so gamitan na siya mga ingon ani mga principles. Okay. Note that the original Fitz law was created for interaction with everyday objects, okay, in the context of operation in factory assembly lines rather than for computer interfaces. So researchers have applied the concept of Fitz law to computer interfaces and have found that the same principle applies. So for instance, no, in a sample in the figure that you're seeing, the task of dragging an icon into a trash can icon using a mouse can be assessed using Fitz law. Okay? Many other computer interactive tasks can be modeled similarly, and several revised Fitz law examples for desktop computer interface, mobile interface have been derived as well. Okay? So, gigamitan na sila sa iyang principle. Next, let's discuss the motor control. Perhaps the most prevalent form of input is made by the movements of our arms, hands, and fingers, no? For keyboards and mouse input, and even in the smartphones, di ba? Kamot mo gitong ginagamit. So, Berard et al. Have reported that there was a significant drop in human motor control performance below a certain spatial resolution threshold. So for instance, while the actual performance is dependent on the form factor of the device used in the model of operation, the mouse is operable with spatial resolution on the order of thousands of dpi, or that's per inch, or 0.20 mm. Okay, while the resolution for a 3D stylus in the hundreds. Okay. Next, in addition to discrete event input methods, samples, buttons, modern user interfaces make heavy use of continuous input methods in two-dimensional 2D space. Example, mouse, touchscreen, and increasingly in the 3D space, haptic or Y-mode. While the human capabilities will determine the achievable accuracy in such input methods, the control display or CD ratio is often adjusted. Okay, the CD or control display refers to the ratio of the movement in the control device, example mouse, to that in the display or the cursor. Okay, so if the CD ratio is low, the sensitivity of the control is high, and therefore travel time across the display will be fast. So if the CD ratio is high, sensitivity is low, and therefore the fine adjust time will be relatively fast. Okay, so as easy as that. And then the others. So there are many cognitive, perceptual, and ergonomics issues that have been left out. Learning and adaptation, modalities other than the big three. We have visual, aural, and haptic. Tactile. There's a space actually must be here. So such as gestures, facial expression, brain waves, physiological signals, and physiological signals in electromagnetic, heart rate, skin conductance, gaze, etc. And then aesthetics and emotion and multitasking. Oh, so that would be all for this chapter. Okay, so in this chapter we have reviewed again, guys. There might be things na lisod kayo sa sabton. Just get the small concept, no? That when you actually design, muni nga mga principle ang gigamit, na muni ang mga ginagamit sa isa ka user. Okay, we use the the eyes, the nose, smell, the ears. Now, okay, so just we have reviewed the essence of human factors, including the sensation, okay, the perception, information processing, and then the Fitz law as the foremost underlying theory of the design of interfaces for human-computer interaction. So by the very principle of know thy user, it is clear that the HCI designer must have a basic understanding of these areas so that any interface will suit the user's most basic mental, perceptual, and ergonomic capabilities. Okay, so we can also readily see that many of HCI principles discussed previously in this book naturally derive from these underlying theories. Okay, so I hope you guys have learned something. If there are things na lisod sabton, then feel free to search more about that thing. What's the most important thing is you learn the basic. You learn the basic theory and then apply it when you actually design of your own system. So that would be all for this video. And thank you so much for watching. Thank you so much for your time. Have a great day and God bless to you.